Hello! In this video we're going to go through learning target 131, which is to be able to write a linear equation while creating a real-world scenario within some given parameters. And then you're also given a graph for that information to be based on. So if we are given a graph, we can then work backwards and write the equation by doing two things. The easiest equation to write is y equals mx plus b, so our slope-intercept form. And so to write that type of equation, you need m and you need b. So we need to finding the y-intercept, which is b, and the slope, which is m. And so given the graph, you need to find your y-intercept from your graph and then your slope from your graph, and then you can use those to write the equation. The other thing that the learning target said we were going to do is to create a real-world scenario. And so we need to then interpret what these are going to mean inside of a real-world context. And so our y-intercept in a real world is always our starting point. And our slope is always our rate. So how fast something is changing. Let's go through a couple examples. So these are kind of like the two types that you're going to see. One is where you're just given a graph, and the other is where you're given words that describe a graph. So in this one we have just our graph, and the two things you need to find are m and b. So we can write our equation in y equals mx plus b form. So I need my m and I need my b. Well, b is a little bit easier to find because it's just on the graph. Our b is our y-intercept. So I'm going to go to the y-axis. I'm going to see where it touches, and that's at 0. So b is 0. And then our m, we're going to count our rise over our run. You could also do the slope formula if you wanted to. And I'm going to write that slope formula down. I'll write it right here in case you want it. That will always be accurate if you use the slope formula, but I think counting rise over run is faster, so I'm just going to do that. And so I'm going to find the next dot that's on the corner, which happens to be here. And I'm going to count my rise over my run. Be careful when you count your rise and your run, because these real-world scenarios especially are not always going to count just by ones. So if you notice, every 2 boxes is 100. So that means every 1 box is 50. So I went up 50. Positive is my rise. And then my run, I'm going to go over, but in this case, every 2 boxes is 5. So every 2 boxes is 5. So if I cut that in half, that's actually 2.5. So 50 over 2.5. And then I'm going to try to figure out what this is by dividing that. So I'm going to divide in a calculator 50 divided by 2.5, and we get 20. You can typically leave this as a fraction, but not if there's a decimal in it. You don't want fractions and decimals to be mixed. So if there's a decimal, just divide it and see what you get. It's usually a whole number. And so the m and the b is all we need to write our y equals mx plus b equation. So I have y equals, my m is 20, x, and then my b is 0, so I don't even need to add it. This is my whole equation. And then sometimes the scenario will tell you like what to write about. So like in the second one, it tells you like to write a scenario about money in a savings account. And sometimes it doesn't. So in this case, we can just make up whatever we want. I just have to make sure it makes sense. So my starting point is 0, and then I'm going up by 20 every time. So I'm going to say that like school is selling tickets to the dance for $20 each. So that makes sense. They would start with $0, and then every person who buys a ticket, X, it's going to be making $20. Now you can go ahead and pause it if you need any of this work, and then we'll continue with that second problem. So in this second problem, it's the same thing, but we're given a description of the graph instead of the actual graph. So it says the graph has a slope of -5 and a y-intercept of 200. And then we want to write the equation and then create the scenario. So in this one, I already know my m and my b, so I can just write my equation. Y equals -5x plus 200. So my m and my b. And then we need to write a scenario about money in a savings account. So I'm starting with my b value. So I'm starting with 200. In this case, it's money, so I'm starting with $200. And then I'm going down by 5. The other thing I don't really know is like what the variable means, and so you can decide what that means in your own head. As long as it's related to a savings account, that's fine. And you can see that it's going down, so we need to be like removing money from the savings account. So I'm going to say like Joey had $200 in his savings, and he withdraws $5 every week. So withdraw means you're taking it out, so he's taking out $5 every week, so that means it's going down, and we started with 200. So there is one more example. I'm not going to go through the whole thing, but I'm just going to pick out the important pieces for you so you can see it. So pause it if you still need any of this there. But then this last one, we have another graph. We can see it's going down. And then again, when you're given a graph, you need M and you need B. So my B value on my y-axis, B is 360. And then my M, if I wanted to go count my rise and my run, I'm going to go down. It's one box, but I'm going down 20. And then I'm going to go over 1, and that actually is counting by 1. So negative 20 over 1 is negative 20. So my equation is y equals negative 20x plus 360. And then you can write any scenario you want. This one doesn't tell you what it has to be about. So I think the one in my example from class, I said that you filled up your gas tank, so you had 360 miles that you could drive, and every gallon you drive 20 miles. And so that would account for this. You could also do something about money. So you had $360, you spend 20 every month, and so you can use that. As long as it's clear that the slope is going down and you start with 360, the scenario should be fine.